Tamerlane, and I'd first like to acknowledge that I joined the meeting from Ngunnawal country in Canberra, where the Australian Water Partnership is headquartered. I pay my respects to the traditional owners of all the lands from which we meet today, and I pay my respects to elders past, present and emerging, and we thank them for their ongoing care of country and waters. So I'd like to welcome you today to this interactive planning session, helping Australia prepare for the 26th Conference of the Parties, or COP, of the United Nations Framework Convention on Climate Change, to be hosted in Glasgow, Scotland from the 31st of October until the 12th of November. We all know that water is central to our lives and to any measures humanity takes to climate adaptation and resilience. Water crises have been identified in the top 5 global risks in terms of impact by the World Economic Forum. Yet surprisingly, this is the first time water has been granted official space at a UN climate conference in the Water and Climate Pavilion. Although maybe it's not so surprising that this special nexus between water and climate change has only become especially obvious in recent years. Indeed, the text of the UN Framework Convention on Climate Change mentions water only once in the whole text. In Article 4.1e, dealing with commitments and cooperation around adaptation to climate change impacts. You can Google that yourself if you don't believe me. So, establishing a dedicated focal point for water issues at COP26 represents a great effort led by the Stockholm International Water Institute, the AWP partner, IUCN, the World Conservation Union, and the Alliance for Global Water Adaptation. AWP responded by presenting an event proposal which has recently been accepted. The AWP event will run virtually at the Water Pavilion in the blue zone of the conference, which is usually a closed UN-managed space for international climate change negotiators. Like a lot of the arrangements around COP26 this year, which is being held in a hybrid format for the first time, details are only now becoming clear about how events and sessions will operate. When we sent our event invitation, we thought the blue zone events would be closed. However, we've just had confirmation from the organisers that anyone will be able to access and join these events online. So this is great news for the Asia-Pacific Water for Development community. It does seem that we can make a contribution to strengthening the Asia-Pacific voice throughout the Water Pavilion and the events going on in the margins of the conference. So as the pandemic has made participating in global dialogues like this more difficult, we've taken the opportunity to highlight and support the presence of Asia-Pacific voices at the Water Pavilion at the Glasgow conference. This aligns with the key message of an important report that we hope to launch as part of our event, entitled Climate Change and Water Security in the Indo-Pacific Region, Risks, Responses, and a Framework for Action. This report proposes that a socio-ecological approach is critical to understanding water and climate risk and resilience in our region. We pitched a storytelling session with speakers from the region and a discussion. Our session will also blend in art and other kinds of storytelling responses. And to this end, we've invited you all here today, as you may be able to add to the various elements of what we have in mind. Today, we're privileged to have Professor Scott Power join us. Scott is a climate science advisor to the Australia-Pacific Climate Partnership, a major program funded by the Australian Government Department of Foreign Affairs and Trade. And Scott will update us on the latest Intergovernmental Panel on Climate Change report on what the science is currently saying to us about climate change impacts on water. We'll then move to a participatory session, as Tamerlane explained, facilitated by Tamerlane and in the breakout rooms by AWP team members, which will play a critical role in shaping our thinking about the connection between water resource management and climate adaptation that we'll present at our event at the COP. We'd also like you to consider what else we can all do as individuals, as organisations and coalitions to make sure hearing diverse viewpoints and lessons becomes a normal part of the work we do. We've also invited again graphics scribe Gavin Blake, who's worked with AWP before, and he'll create an image to summarise the session outcomes from today. As Tamerlane has explained, this image and the stories it will build on will become a visual and messaging anchor for our session at the Water Pavilion at COP26. This session's an invitation to add your voice, and we're very grateful for your time and your stories as part of this session. And I'll hand back to Tamerlane now to facilitate the rest of the session for us.
Thank you so much, Michael. And welcome everybody. Just one request. We're not going to do detailed introductions because time is really short and we want to get into breakouts and hear from Scott as soon as possible. So if you could please just click on your name on the participant list. So you can either click on participants on your menu bar at the bottom, and when the participant list pops up, hover over your name and rename yourself, just to put in brackets your organisation that you're representing today, so that at a glance we can know, particularly when we come into plenary discussion, who we have in the room and who's talking. So at the moment, it's you can see Federico de Villa has already got ISF, UTS, thank you, and Catherine Cross from AWP Mekong Coordinator has provided an example there. So if you just hover over your name in the participant list and rename yourself by your organisation, that would be very, very helpful. So without further ado, it's my great pleasure to introduce, well, hand over to Professor Scott Power, who obviously is incredibly experienced in this space, Director for the Centre for Applied Climate Sciences at USQ, Adjunct Professor at the School of Earth, Atmosphere and Environment at Monash University, and Associate Investigator, ARC Centre of Excellence for Climate Change. So I'm going to now hand over to Scott. And Scott, if you can unmute yourself and just tell me when you'd like to progress slides, that would be great. Thank you.
Great. Thanks very much, Tamerlane. Good afternoon, everybody. It's a pleasure to be here. And thanks also to Lucia and Sarah and their colleagues for organising the event, and for Michael for hosting it. Next slide. Thanks, Tamerlane. So I'm going to be talking about the one prior to that. Thanks. Yeah, so I'm going to be talking about the latest IPCC report. IPCC stands for Intergovernmental Panel on Climate Change, and it's the world's foremost authority on climate change, on the science of climate change, and they deal with three different topics. The first is about physical science, which is what I'll be talking about today, and the report came out in August. There's another report next year, early next year, on impacts, adaptation and vulnerability, and a further report later next year on the mitigation of climate change. So that's concerned with reducing global greenhouse gas emissions. So as I said, I'll be focusing on the physical changes today in the report released a couple of months ago. Thanks, Tamerlane. Next slide. And it's a very impressive report. It's approximately 4,000 pages long. It has 234 authors from 65 different countries. And in the course of producing that report, the authors assessed 14,000 or more than 14,000 scientific publications, and they considered review comments. So it's been peer reviewed to death. Review comments, 78,000 review comments, or more than 78,000 review comments. So each and every one of those was considered, addressed, and that goes into making the quality of the report extremely high. Next slide, thanks. So let's now move to summarising just a small subset of some of the main conclusions relating to the water cycle. And the main point to note is that the Earth's water cycle has already changed in response to human activities. Next slide, thanks. And one example of a few is that the observations exhibit changes in heavy rainfall and the frequency of drought and the severity of drought. And in the places where you see those little green blobs down the bottom, that shows where there's a degree of confidence that the change observed has been partially due to human activity in heavy rainfall. The one on the left, where there are gold blobs or hexagons, shows you where there is a degree of confidence that humans have given rise to trends, changes in the observed frequency or intensity of droughts over the past 70 or so years. Next slide, thanks. So let's now look at the future, and the report provides a wealth of information on what is projected to happen in the future. And a lot of the information comes from climate models, which are forced by varying scenarios of greenhouse gas and other factors. And so in climate science, we consider scenarios in which emissions are markedly reduced in line with the Paris Agreement, but we also consider scenarios where the agreement fails and emissions of greenhouse gas continue to rise or stay at their current levels. And so what this shows is projected changes, percentage changes in annual precipitation across the globe for 3 different levels of global warming. So the plot on the left shows what's the projected change in annual precipitation for 1.5 degrees Celsius global warming. The middle panel shows the percentage changes in precipitation under 2 degrees global warming, and the one on the right shows the projected changes in annual mean precipitation under 4 degrees of global warming. And the shading indicates percentage change. So the greens indicate that the precipitation increases, the mean precipitation increases, and the browns and the rust colours indicate that the precipitation declines. And the first point to make is that the patterns don't vary very much between the scenarios, but the magnitude of the changes definitely does. So as the planet warms, the associated changes in precipitation, but all of the other array of changes, sea level, etc., all tend to get larger as the amount of warming increases. And another way of saying that is that, or an equivalent way of saying that, as global greenhouse gas emissions increase, the projected changes tend to increase. And you can see that in some parts of the world, we're anticipating increases in annual mean precipitation, whereas in other parts of the world, we're expecting reductions in precipitation. So it's a complicated story. So you can see that over the southwest of the southern continents, you tend to get drying, also through the Mediterranean, across the Atlantic into Central and Northern South America. But you also tend to get increases in precipitation, I should say, in the Arctic, in the Antarctic, over northern and parts of Central Africa, across through to India and much of Asia, and also in the equatorial Pacific. So it's a complicated picture. Thank you. Next slide, Tamerlane. And another set of conclusions from the report is that continued global warming is projected to not only change the long-term average values of precipitation, but it's also expected to intensify the global warming cycle, including its variability. And as part of that, the projection is that it's very likely that rainfall variability associated with the El Nino Southern Oscillation will increase by the end of the 21st century. And as you know, the El Nino Southern Oscillation has a profound influence on climate throughout most of the Indo-Pacific. Next slide, thanks. And in addition, there are increases in the frequency and intensity of heavy precipitation. And unlike changes in mean state, these increases tend to occur in nearly all locations over land. Next slide, thanks. One before that, please. One after that. Anyway, we'll just concentrate on the top half. So what this shows is the results taken from all locations over land, showing the frequency with which we expect to experience a 1 in 10 year event, or an event that was 1 in 10 year event during the pre-industrial era. So you can see by those dots, that gives you an indication of how much more likely those events are to become in the future and at present. And the numbers beneath those dots indicate a more accurate answer. So in the pre-industrial period, a 1 in 10 year event occurred once every 10 years. But now it's occurring around about expected to occur around about 1.3 times every decade. When the global warming is 1.5 degrees Celsius, it will become 1.5 times every decade, through to 4 degrees global warming, where it's expected to be occurring on average 2.7 times per decade. So much, much more frequently. And the part below indicates that if you just consider what happens to a 1 in 10 year event, so all these events remain 1 in 10 year events, but the magnitude of the rainfall associated with that 1 in 10 year event increases from by 6.7% at the moment, or under 1 degree warming, through to an incredible 30% increase under a 4 degrees Celsius warming scenario. So in summary, the frequency and the intensity of these heavy rainfall events are projected to increase at virtually all locations over land. And another major conclusion is that while the effect of climate change on drought varies across regions, increases in the frequency and intensity of both agricultural and ecological droughts in some regions are projected. Next slide, thanks. And this again indicates, the top one is similar to the last plot, gives you an indication of how much more likely a 1 in 10 year event, or an event that was 1 in 10 year event during the pre-industrial period, becomes in response to global warming. So you can see that it goes from once in the pre-industrial climate through to over 4 times more likely under 4 degrees global warming. And if we look at the intensity of these droughts, these agricultural and ecological droughts, which are a measure of the dryness of the soil, they increase. The magnitude of the 1 in 10 year event increases by a very marked 1 standard deviation of the variability that it experiences. So that represents a very major shift to drier conditions over land. And then another major conclusion relates to flooding. And a warmer climate increases the amount and intensity of rainfall during wet events. And this is expected to amplify the severity of flooding. However, the link between rainfall and flooding is complex. You know, if you get a high degree of rainfall, but the soil's dry, then it may not cause flooding. So the link is complex. So while the most severe flooding events are expected to worsen, floods could become less frequent in some regions, particularly if the long-term average rainfall is diminished. So the story there is that we need to focus on, there's no blanket statement that one can make about how flooding might change. So in summary then, the IPCC report concludes that major changes to the water cycle have already occurred and further changes are projected. And that's the bad news, but the good news is the more we reduce net global greenhouse gas emissions, the smaller the projected changes become. And we saw that there's a degree of complexity because the sign of the projected changes to annual precipitation, and by the way, the same is true for seasonal precipitation, for winter, spring, summer, etc. While the sign of projected change varies from place to place, the frequency and intensity of extremely heavy rainfall is projected to increase almost everywhere over land. And finally, we saw that precipitation variability about those long-term changes is projected to increase in many locations, including variability driven by the El Niño Southern Oscillation. And then the very last slide is just to reflect a little bit on what this all means. And a few reflections are that, first of all, the past is no longer a good guide to the future. And in particular, we may need in certain contexts, in many contexts to be frank, need to plan for events that go beyond historical experience. So we're going to see, we already are seeing unprecedented events, and we will continue to see events that are unprecedented, even if we take into account our very recent experience. And we touched on the fact that, yes, planning is clearly prudent, but it's complicated because, for example, projected changes and their implications vary from place to place and context to context. And there is great uncertainty about future climate at very local scales. And in this presentation, I've focused on the direct impacts of climate change on water, but of course there are many indirect important effects. So for example, we know that sea level has risen and further sea level rise is inevitable, and that is very, very markedly going to increase the frequency with which we'll experience coastal inundation in many locations, including many low-lying Pacific Island countries and some low-lying countries in the Indian Ocean. And so that indirect effect will have a detrimental effect on water quality and in some cases water supply. So thanks very much, Tamerlane.
Thank you so much. What a great presentation.